Last week, we talked about the overall 3 longevity levels. There's level 1, level 2, level 3. Level 1 is 6 things, and one of them is calorie restriction. The key thing with level 1 is to understand that if you do all 6 things in level 1, you have a 95% chance of living to age 75, and a 50% chance of living to age 94, and a 5% chance of living to age 98. This is without doing any of the level 2 or level 3 stuff. And the calorie restriction component within level 1 gains you plus 5 years versus if you don't do the calorie restriction. And this is based on computer simulations, because we haven't done studies which last for 60 years in humans, or 10, 20, 30, 60 years. But we have done them in rhesus monkeys. So they're monkeys that normally live around 30, 35 years. And we've also done studies in other model organisms, and also shorter term studies in humans lasting about 10 years or so. And it's combining all of these data together across all the data that we have, that we can come up with an estimate of how much impact it'll have. So the estimate from this computer simulation study was plus 3 to 7% increase in life expectancy. And so the middle of that is 5%. And then if you add 5% to around 80 years, or your life expectancy, when you're doing the other parts of level 1, it comes out at around 5 years. So that's a little overview of the potential of how it fits in with the levels framework. So it's a level 1 intervention because there's good enough evidence to suggest that at least in men, not women, it adds at least 2 years of stackable healthy life expectancy to people, to most people. And that's the requirement to be a level 1 therapy, to have good enough evidence that it adds at least 2 years of healthy life to most people. So restriction normally means you're doing it below the RDA or the NRI. So the RDA is like recommended daily allowance for men. It differs for everyone, but for men, it's normally around 2,500 calories. For women, it's normally around 2,000 calories. If you're doing calorie restriction, it means, you're going below your personal RDA. So if your personal RDA was, 2,700 as a man with a high metabolic rate, then it could be doing 10% less than that. So normally you need at least 10% restriction to gain maybe at least 50% of the effects, is a kind of reasonable estimate. But the maximum effects may be 20% reduction, or even a little bit more. So that's the kind of what it means, calorie restriction. And then that's the first. You never want to do calorie restriction by itself. So that's the first 2 letters in the acronym. So the acronym is Cron, C-R-O-N. And the O-N part stands for optimal nutrition. And what that means is basically you're tracking every micronutrient and macronutrient and micro and macro toxin as well, you could say, and making sure you're not getting any deficiencies or insufficiencies in all those nutrients. Because it's very risky with calorie restriction that because you're eating less calories, you can very quickly, over a matter of months, start accumulating deficiencies in multiple vitamins or minerals or other essential things, etc. So it's always Cron. It's never CR. It's always Cron. And it's the same in the studies, really. They always make sure that the participants in the studies are having enough micronutrients and macronutrients to get them above their RDA level for those macronutrients, so that they're not getting deficiencies, even though they're having less calories overall.
One of the best ways to determine if an intervention actually works in humans is to trial it in animals that are closely related to humans. Now, there's a couple of experiments which are really big in the calorie restriction with optimal nutrition sort of space, carried out in the United States at the University of Wisconsin and the National Institute of Aging, on the NIA, which looked into calorie restriction in rhesus monkeys. I was just wondering if you could dive a little bit into that, and what's the framework of the studies, and what were the results, and what did they tell us more about calorie restriction?
So there's 2 studies. There's UW and NIA, And in each study, there was a control group where they had a certain amount of calories, and then an intervention group where they had less calories. And there was then subgroups within these where they either started it before, depending on the study as well, there's different subgroups. But in one of the studies, there's a subgroup where they started it before adulthood, like quite a young age. And then there's the other subgroup where they started it like age 40 plus human equivalent. And so the summary to take away from it, once you're looking through all the data, is basically it doesn't work if you're starting it before you're fully grown. It's only going to work for if you're doing it after you're fully grown, and it's probably only going to work if you're a male, but it may still work a little bit if you're female. And so if you're male, by that I mean it's going to increase based on this study, it's going to increase your life expectancy and health expectancy. But if you're female, because you're already living a bit longer already, potentially because the RDA for females is already 2,000 calories, so you're already kind of naturally doing 20% calorie restriction compared to men. The monkey studies didn't show that it increased overall life expectancy, but it did increase health expectancy. So they had less bad aging and higher quality of life for a lot longer compared to the female monkeys that started calorie restriction when they were fully grown and then did it for their whole lives. That's the key thing. It's not like they did it for 1 year and then stopped, but they're doing it for their whole lives. Some of the control groups were already undergoing a bit of calorie restriction already. But then if you compare the groups between the studies, adjusting for those calories, and also against the historical data of like the several thousand monkeys they have in the database of this breed of monkeys that they have, when you adjust for the calorie intake in the control group, you find that, yeah, it does work a lot. And you're like 417 times more likely to be a monkey centenarian equivalent if you're doing, if you're a male doing calorie restriction than if you're not. So monkey centenarian equivalent is like living to age 40 as a rhesus monkey in this breed of monkeys. And that's pretty crazy. So yeah, if you like look at the rates of rhesus monkeys that normally live to age 40, it's kind of the same as the rate of humans that naturally live to age 100 without any advanced medicine. It works in a lot of model organisms. So naturally aging mice, the ones that aren't genetically modified to be quite different from how they are in the wild. So yeah, mice, it quite reliably increases mouse maximum and medium lifespan. And what that means technically is that when you look at the Kaplan-Meier survival curve, it increases the 90th percentile and the 50th percentile. Basically, it's like the percentage of surviving animals. It's the percentage of surviving animals over time. So you have a number of days on the x-axis, and you have percent of mice or monkeys that are alive by a certain age.
Obviously, we talked about animals. Is there many people that have actually tried Cron for an extended period of time?
Yeah, we got some crazy data on them showing that it does crazy things. So we've got a good slide on that, actually. We can just show it for a sec. It's really detailed. So it's more like something you should pause the video for, then look over and put it in high resolution because there's quite a lot of text there. But basically, this is a summary of all the markers that I found an effect of human calorie restriction studies for. So some of these studies have been going on for like 15 years, where people have been doing 20%, 30% calorie restriction. Because there's this thing called the CR Society. I've never really looked into it much, but it's people that it's like a online forum for people that do CR, and then people researchers found it, and then they started using them as participants based on the fact that they're on this forum. Because there's people on this forum who have been doing CR for up to 20, 30, 40 years, even some people already. So you get that really long-term data, which is pretty crazy. So obviously it's not a randomized controlled trial, but the next best thing to a randomized controlled trial is a non-majorly flawed, non-randomized controlled trial. But there's no control group either, other than themselves and virtual controls, which is fine. Like, it can be fine as long as you have a large enough effect size in the biomarkers, which we do see here. So it's very unusual for people to have no just like perfect arteries, perfect blood pressure, perfect BMI, perfect insulin, perfect body fat, perfect visceral fat, that's organ fat, perfect inflammation levels like CRP, perfect LDL, HDL, total cholesterol, triglycerides, TNF alpha, which is like marker of senescence associated secretory phenotype, SASP, which is like a surrogate marker for whole body senescent cell load activity. Perfect, like HRV as well. It's like that's quite hard to increase. So that's like 20 to 30 years younger than their age, and you don't normally see that much. That's pretty insane. So basically, and then there's like a load of biopsy markers where they look at the mRNA levels, and they're all like crazy. You don't see that in any other therapy ever. So yeah, the human biomarker data is very, very compelling, and it completely supports the plus 5 years life expectancy you'd gain. I've been doing CR myself, so I can speak for myself. I've been doing it for like 7 years. So I'm 27. Been doing it since like age 20. And
how have you found that?
It's like, yeah, it's just effortless because it becomes habit. It's like anything really. It's like exercise or normal diet or anything else. It just becomes like the first few months is really hard, but then because you have to think about it and it's like active thinking, but then it's like super easy. Yeah, there'll be a lot of mRNA changes. So on that slide we showed before, on the right hand side actually, it shows all of the like percent changes you see. I think this is on like a muscle biopsy from one of the studies I'm referencing. So you see like the sirtuins there, which are like very important proteins for protecting various parts of the cell. They increase hugely. So it's changing your levels of gene expression a lot. I think like ATP synthase goes up 600%. PGC1 alpha goes up 600%. Those are very important things for cell protection, mitochondrial biogenesis, etc. So yeah, at an epigenetic level, it's going to change as well, because you're not going to have those changes in mRNA unless you're seeing changes in epigenetics. So yeah, it has huge effects at the mRNA and epigenetic level. But obviously it's not going to change your genes, but it will reduce your risk of cancer, and increase your DNA repair capacity, so it'll reduce your rate of somatic nuclear mutations and probably mitochondrial mutations in the mitochondrial DNA that is outside the nucleus as well.
What is the difference between calorie restriction and intermittent fasting?
So intermittent fasting, it doesn't have anything to do with calories. It's just to do with like your eating window. So you can do intermittent fasting but still eat the same number of calories, or you could eat more calories than you would normally. So it has nothing to do with calories. But yeah, there's like some mice studies which show if you do isocaloric, so same number of calories, intermittent fasting, where I think, so they were doing alternate day feeding, then the mice would live about 10% longer in both median and maximum lifespan. But this was only, I think there's only one study on that, so it's not like super validated pre-clinically, and it's not in monkeys either. So the evidence base is like 100 times more for calorie restriction. It's literally 100 times more in terms of aging impact. But often the confounding factor in real life is that people, when they do intermittent fasting in whatever form, whether that's 16/8 or OMAD or alternate day feeding or prolong or whatever, or 5-day fast once every few months, you find that they're not actually just doing isocaloric intermittent fasting, they're doing hypocaloric. So they're doing calorie restriction plus intermittent fasting. And then the benefits are going to come from calorie restriction on top of intermittent fasting.